Good evening, everyone. So I think it's time I can start the class. I have shared the Google Collab link in the chat box. So again, I would request you to make a copy of that and simultaneously, please try uh, doing the all the processing which I am doing. Yeah. So today we are going to do a hands-on training with Python for SVM kernel, that is support vector machine. So can anyone tell what support vector machine is and how it is? Because in previous classes, what we have done is we came to know different kinds of algorithm for machine learning, that is linear regression or linear classification, then logistic regression, then how the data are being called, what kind of data can be used, and where these algorithm can be used. So today, yet another algorithm of machine learning, that is support vector machine. We are going to deal with it. So can anyone tell me what is support vector machine is? I hope I'm audible. I hope I'm audible, right?
Yes, ma'am. It is a supervised learning algorithm. It is used for both classification and regression problems.
Yeah. So why this term called support vector? Okay. So I don't want to go into the theory, but overall, I would like to give a just a clarification. So support vector machine is obviously is for supervised learning. Supervised learning means those classification or those algorithm which have labels. Labels as in we already know what kind of data it is. So we have the ground truth of that. We have the labels. For example, if we are going to classify between dog and cat, we know this is dog, this is cat. So that is what labeling is. So we know. So support vector machines are supervised learning algorithm, and that can be used both for classification, that is either 0 or 1 values, or regression, that is a continuous values. Okay, which is in the form of percentage. So but most of the time we prefer to use it for classification purpose. So how do we do a classification problem? The best way to do is separating into a hyperplane decision boundary. So for visual purpose, I have shown you two images, right? So in that images, if you can see, let's consider this as h1. The my left hand side is considered as h1 hyperplane, and the right hand side is called as h2 hyperplane. So what difference can you find in it? In first figure, if you will see, the margin or the this is called decision boundary, or a margin or the fit line, what you can say, is able to distinguish between two classes, that is my red and blue, right? While for the second one, the margin between these two lines, these two classes, is higher. That is, the width is wider compared to the H1, which where is narrower. So there are something called hard SVM and soft SVM. So if you can see in H1, we have 100% accuracy. 100% accuracy means neither of the classes is on this line, that is H line. So this means, and this M means maximum margin. So by this margin, both the classes are being separated. I'm sorry guys, if you guys are typing anything in chat, please do speak up, because I'm not able to see the chat in between. Or if you have any queries, yeah. Muhammad Yunus, but please, you have any question, please ask me. Okay. Okay.
Ma'am, please share the collab link once again in chat box.
Yeah, it's done. Okay. So what I was saying is, this is the maximum margin that is needed for separating these two classes. If we increase this margin, there are some misclassification as in these classes, these blue classes are coming to the red classes part, and the red are going to the blue part, right? So there is some misclassification. So there's something called soft SVM and hard SVM. So the first part where the max, the whatever it is required, the margin that is required and which is giving 100% accuracy in the first case, that is called as my hard SVM. And the second part is called my soft SVM. Why? Because we are maximizing our, okay,
Margin.
I hope you guys know the theory about it. I Because I'm not explaining it in very detail, but I just wanted to give an overview so that it will be easier if we go with a hands-on training. So, in short, the first part is hard SVM, because narrower the margin is, along with that, the classification is more accurate. While in soft margin, we are increasing our margin, that is the this decision boundary space or decision boundary length, but my classification is decreasing. So there's something called regularization parameter, which is defined as C. Okay. So in hard margin, the regularization parameters are generally large values. Why? Because the narrower the the width, the larger the regularization parameter is. Similarly, for soft margin, my regularization parameter is small. Okay. There is one another significant parameter that is called gamma. So these are the two significant parameters for SVM, that is C, which is termed as regularization parameters, and then there's something called gamma values. For if I have shown the gamma values, yeah. So if you can see, for high gamma values, there are very few data points that are influencing the decision boundary. If you can see, like, it's almost taking all the data, and my decision boundary is less, right? So this lead to overfitting. This can lead to overfitting. While my small gamma values have less influence on decision boundary. If you can see from both the figures, and that is, this is what it is preferred. So just remember, for this exercise, what I'm going to tell you about is, I would show you how I can work with different regularization parameters, that is C, different gamma parameters, and how these SVM are being influenced with some visualization. So one thing is hard and soft SVM. Second thing, in SVM, we just not deal with the linear functions. We have non-linear functions as well, and that is where SVMs come into picture. What is linear and non-linear? So in very simple term, if I would say, for example, if I'm going back to my this example, I can consider it as a linear example. Why? Because just with a single line, I'm able to separate these two classes. So these are linear SVM. But there are problems, like you can see in this example. Just with a single line, you cannot separate two classes. So there's something called non-linear. So how you can go into a non-linear? By increasing the dimension. What does that mean, and how does can be done? So I'll tell you, I have explained that as well. But in short, there's something called kernel. Kernels are mathematical function, which trick my SVM from taking it to a smaller dimension to higher dimension. I'll just give you a very small example. We all know, in mathematics we all have read about a plus b ka whole square, right? So if I talk about a plus b ka whole square, that is, let's consider it is, and this is may not be a very reasonable example, but this is what I can tell you, how the kernel trick SVM from taking into a smaller dimension to higher dimension. So if we talk about a plus b ka whole square, this is, I consider it as one dimension. If I'm going to expand it, that is a square plus b square plus 2ab. Now I have three terms in it. let's assume I'm considering as 3 dimension. So the same formula, a plus b ka whole square, same formula that is from 1 dimension, it is being converted into 3 dimension. So this is just to let you imagine how kernels are helpful in taking SVM from a linear to non-linear or a higher dimension. So that is where my kernel functions are used. We'll go into that later. Now I hope I'm clear with a few of the basics of SVM, and I'll proceed with my programming thing. So again, I have to load the libraries. Again, I would repeat the same. It's not necessary that you have to load all the libraries at a time. It's pretty much convenient to do so. So what I always do is, for example, if I know in the next line I need, for example, pandas. So I will just import pandas in that example. The later stage, if I need numpy to be in import, I will again come to this cell. I'll again write numpy as np and I'll again run this cell. It's more of I like to keep all my libraries which I'm going to import in one cell. But obviously it's not necessary that you have to do the same, but it is a very general practice so that you will not lose the way while doing your coding. And if the coding is a very big process, like it's a very big problem. So okay, the required libraries, I have done that. Now I'm taking obviously the standard data set, I'm just taking for it so to show you. So there's a data set called iris. You can easily get it if you just type iris data set. So these data sets are easily available and I'm just importing it from sklearn. So I'm just taking the data, and over here what I have done is I've not.
Kaushiki,
Yeah, please tell me.
yeah, actually in the assignments they said use a modified iris dataset. So isn't that a little bit confusion creating, because how do I know what is a modified iris dataset?
Okay, so modified iris data means the data set which, okay, so if you will see the iris data set, it's a very long data set. It has so many columns and rows which you don't need to work on. Okay, so modified iris means just to take those data which is required for your model at that time. For example, the same thing I have done. I don't require the whole data set, and it will like unnecessary will fill my memory and take more of computation time. What it done is I just wanted to show you like in some features. There's so many features in that. There's so many data in that. So I just took the first two features. So that is what I did. I just put a colon, comma, colon 2. This means I have just taken the first two features, and those first two features, the whole data set can be considered. The whole rows can be considered. So this is what modified iris means.
But shouldn't it be properly explained in the question itself that you have to consider so and so rows? Otherwise, it becomes ambiguous, right?
Um, yeah, okay. That I think you have to consult with the TAs because I'm not involved in that question. I'm so sorry.
Yeah. Just as a
And
clarification, I was asking, since the question arose, you are importing the
yeah,
iris dataset. I thought I'd
as
ask
far
you at
as
that
my
point.
knowledge, I think that is what the modified iris means, because obviously there's no need of working on the whole lot of data set because there will be so many rows and columns, and there will so many features which we don't require. So just to
But how you are selecting the first two features? It's arbitrary, or it has some scheme to it?
you
Is
can
how
select you can select any features. What I do is I just check the data. Okay, what kind of features are there? And I think just to like for this example, I don't need other features. There are just two features which is sufficient, which can show two different kinds of data. That's it. And if we talk about my last class, for example, I guess it was logistic regression, and we were solving where we have to find radio and between radio and different advertisement, how the sales are increasing or decreasing. So in that scenario, there were so many data, but we needed to choose some particular data only. Like there were, I think, there was one user data set as well, where genders was there, where other user id was there, or the other information which was not relevant. What was relevant was I just needed the data set which can relate to my output, the predicted output. So that is
yeah.
how you have to like figure it out.
So you have to probably do a preliminary EDA before proceeding with this thing, right?
Yeah, exactly.
Yeah, yeah. Okay, okay, fine.
Okay.
So, hello.
Yeah, please go ahead.
For a real-time data set, we have to first analyze the whole entire data set, and then we have to select from the.
Yeah, obviously, for any kind of data set, if you're going to see, right now what I'm working is a standard data set, right? So we don't need to, I don't need to look into the null set of data set, or if the data set is good enough, or what kind of data into it. So the first part, okay, for, if you're working in a real time environment with machine learning, the first and foremost role is to work on your data set. How you are going to know what kind of algorithm you are going to work, what processing is required on that data set, unless you know your data, what kind of data it is, and what output do you need to generate. So first thing is that. Second thing is, again, okay, if I'll get a chance, definitely, like, when I'm done with these classes, for sure I'm going to take one class where I'll show you all the processing. I think I already have that kind of example with me, where I can show you how, first, just having the data, I can just first scrutinize the data from it, and I can just do the pre-processing, remove all the null values from the very basic. I think I'll take a class, one or two class for that. And I think that, because in every class I'm getting the same question. So yes, obviously you have to do the pre-processing first, and then only you can move forward with your algorithms or any kind of thing. Okay, so I'll make sure to do that. I don't know if I'll just have a conversation with other TAs, and I'll make sure I'll take that class. Sorry. Okay, now my this data set has been loaded, right? So I want you to show the decision boundary. So how I can create a decision boundary function, what I have done is, i have I have taken, these are just the markers, like, if how do you want to represent your data, that's it. Or the colors, and the color map is like, what kind of colors do you want to give. It can be red, blue, green, any kind of color map is there, right? And these are just the mesh grid is another kind of function, which, what kind of representation you want. So yeah, this is just the representation purpose. Don't think about this. This is just a decision boundary function which I have created. Now I would like to go again where I have to train and test my data. So I'm doing a train and test splitter, and again I'm doing the standard scalar, which is for standardizing my data. These are the same process for every function, every algorithm. Either we do linear, logistic, SVM, other algorithm which are coming forward. Everything will be having same. From sklearn, we are going to import train and test split. Then we would be doing the standard scalar using pre-processing, and then we will be taking xtrain, xtest. Will be our taking the test size. This means I have divided my data into 70-30 ratio, and I'm fitting my data with xtrain. Then I'm taking doing the transformation on xtrend data and xtest data. So these are the same process. Now I need to implement my soft and hard SVM. So how we are going to do that? So I told you how we are going to find that. There's something called regularization parameter, C. So with the value of C, we can actually make our SVM a hard SVM or a soft SVM. So soft SVM means my decision boundary can expand as much as it want. That is why it is soft. You can formulate it any way you want, but that can lead to misclassification or overfitting, which we termed as. While hard SVM have a fixed decision boundary, we cannot make it beyond a certain range. Otherwise, it will not be a hard SVM, and that is why it is a more generic one, and it gives better accuracy rather than soft SVM, which can lead to overclassification or overfitting. We can say that. So SVC, and SVR, this is the model name which is termed as. So over here I'm considering it for classification purpose. So I have considered as SVC. If this is for regression purpose, it would be SVR. Nothing much difference. Everything would be same. All the process would be same. Just the terminology, SVC or SVR. So I have taken this regularization parameter 10. Like this is how it is represented. 10 cross 10. That's it. Okay. And I fit my model, both X10 and
What
Y10.
is C?
C is my regularization parameters. Over here, I had, okay, I think this is, I just had, I took the class initially when I was explaining the two most important parameter in SVM. One is regularization parameter, that is C, and one is gamma values. So I would be dealing with both regularization parameters, changing regularization parameters and gamma values. Yeah.
Kaushiki,
Yeah. Tell me.
the C is 10 to the power 10, I believe. C raised to the 10 raised to the power 10, I think.
Yeah.
In the first case. C
Yeah. So
SVC.
yeah, the 2 star means power. Yes.
Yes. So it's quite a high value, right? So is it a library default or you have experimented before coming up with that value?
Sorry. What? It
No,
is a.
no. I am asking, is it the library defaults or you have experimented with the parameters before you came up with this?
Oh, we will take different C values. That is why where I'll show you. I'll just go beyond and I'll show you what kind of different C values you can take and how the results are varied.
Okay.
So you can take any C values. I'm just showing you one example.
Okay.
Okay. And this I've considered as hard SVM. Okay.
Okay.
So yeah, the two classes which I considered is sepal length and sepal width. Over here I have given the labels, and yeah, the model I have created as 0.08 text index. Yeah. Anything needed to be explained in that? No. Okay. So this is what this is.
Ma'am, stack will arrange the data set.
Sorry.
The stack, V stack will arrange the data set.
So yeah, V and H means vertical and horizontal. That's it. np.vstack means vertically you have to take xtrain and xtest. np.hsstack means horizontally you have to take ytrain and ytest. That's it. Am I clear? And this plot x level y level, it is simple like this: sepal width, sepal length. That's it. So if you can see, there are data
Huh?
set. Yeah, tell me now.
Yeah. Go, please go on. Sorry. Yeah.
Okay. So yeah, if I can see, I have three data set over here: 0, 1, 2. The box, circular box with red one is the 0. The square red is the 0. The circular blue is the 1, and there's a cross green. If you can see, I should have taken some other color. So yeah, that is a third class. So why I have taken three classes? Because I wanted to show you how if we have more than two classes, because separating just two classes is comparatively easy, right? You can just create a line, and that is what we were doing with our linear regression and logistic regression, which we were using a line to fit it. Over here I'm doing more than two data, and how my hard SVM is taking into role. So what hard SVM is doing, these decision boundary, if you can see the boundaries which are changing colors, those are all decision boundaries. Okay. So how decision boundaries considered in hard SVM and how the classification is done. If you can see, still there is some misclassification, like the classes from green cross section is coming into the blue section. So if it was a soft SVM, it would have considered that also. I'll show you that example as well. But that can lead to overfitting. See, over here I have taken the soft SVM. See, again, this in soft SVM, everything is same. Just the value of C is changed. Right. Now the question would be, how would we know which is hard SVM and which is soft SVM? That I would leave up to you guys, because that is what regularization parameter whole theory is about, right? So you have to check on that. What is regularization parameter? I can just tell you how regularization parameter is used in my SVM. and how that regularization parameter helps in defining a hard SVM or a soft SVM. Okay, so in starting initially only I told you if my like how we are going to define with the with the help of C values. So for hard margin SVM, like SVM, generally the regularization parameters values are high. That is why the C considered over was 10 to the power 10, right? And over here, the soft margin SVM, generally the C parameters are small. Okay. Again, I've considered, oh yeah. So this is done with my SVM. There was another parameter that is gamma. Okay. So gamma is another value which help in like, okay, anyone know about significance of gamma?
Can I attempt?
Yeah, please go ahead.
Yeah. It defines the width of the radial basis function kernel. Means how much from the target point it will consider points to be similar to itself in measuring.
Exactly. So in simple terms, gamma is one significant parameter of support vector machine. It tells us how much will be the influence of the individual data points on the decision boundary. Individual data points, not the whole collective, right? So this is where gamma values come into picture. Again, the the large gamma means there will be fewer data points, like very few data points that will influence the decision boundary. For example, what I mean is, if we have to make a decision boundary, if we are creating a decision boundary, so the main purpose of our SVM is to distinguish between two classes. How we are going to distinguish? We are creating a decision boundary. How we are creating a decision boundary? That depends on the values or the individual data points that is present. So if two data points are very close to each other belonging to two different classes, making a decision boundary will be difficult, right? So that is where these parameters come into picture, which help in making a taking a decision in drawing a decision boundary. Okay, so if there are fewer data points that will influence the decision boundary, that means the gamma value is large. Okay, and therefore decision boundary becomes non-linear. Large gamma value leads to non-linear decision boundary, while small gamma means there are more data points which are influencing that decision boundary. And generally we prefer smaller gamma values. That is, the if we want to make our model more generic, we have to take smaller gamma values.
But Kaushiki,
Yeah.
once you use a RBF kernel, then automatically you are using a nonlinear decision boundary. Gamma wouldn't come into the picture at all, right? Until and unless gamma is zero or
See,
something.
okay, agreed with you, totally agreed. I'll tell you just one thing. Wherever non-linear decision boundary comes into picture or terminology, kernel will be there by default. And by default, kernel for SVM or SVC or SVR is RBF. That's it.
Okay, means even if you do not pass in any kernel parameter, it will
Exactly.
take RBF as a default, right?
By default, exactly.
Okay.
So by default, kernel is RBF, and this will always come if the decision boundary is a non-linear decision boundary or a non-linear function. Okay.
Okay.
So for larger gamma values, that's what I told you. Decision boundary becomes non-linear, and that is why my RBF kernel is there. Over here, I'm taking gamma value as 1.0, and I have also considered regularization parameter 10. Okay, I need to see how my like decision boundary is affected with the same data. And again, the same thing, the same process, like the functions and everything would be same. See, you can see with gamma is equals to 1.0, you can see the decision boundary, right? How this is non-linear, how it is being classed. See, the in between also there are some green patches on blue, some green patches on red. That is what non-linear, and this is overfitting. Why overfitting? Because it is unnecessary trying to separate the classes as much as it is possible, which is not true, which cannot happen, which is not, like these green patches itself tells that my function is overfitting. I can separate all the data points, every individual point I can separate, but that doesn't mean that my model is working fine if I'm going to take any new uh, like if new function is being considered. What I'm saying is, the whole purpose of my machine learning is to automate our function, is to automate our method. So, and why it was done to conserve human power or human energy. What I mean is, if I'm working on a particular set of data set, and if my model is working perfectly fine on that, like giving 99% accuracy and it's perfectly fine, but it should at least give 90 to at least 80 to 90% accuracy if I'm working on another data set which is totally independent from my first data set. That is where my model is working fine, right? So this is the very sigma rule of any machine learning algorithm you are working on. You are tuning the parameters. You can tune the parameters for a particular data set. That should be applicable to other data set as well, right? Or not other data set, at least if I'm going to put some new information on the same data set, it should work on that as well. It shouldn't be like
Yeah,
that.
I should add that you want to make it should generalize well, right? To new
Exactly,
data.
exactly. So this is why my this function or this graph which is showing over here with gamma 1.0 is not good.
And why there is a green blob that is coming into the red island means, is there any data point near to that? Why?
That is what I'm
Probably.
saying. It is overfitting. The
Yeah.
word overfitting is coming over there. It is considering some data over there and it is taking a green patch over there,
Okay.
trying to distinguish it.
What is the reason it's overfitting? Is it because of gamma equals to 1 or
Yeah, yeah.
10?
Like, see, overfitting basically means uh, like it is try to separate the data set as much as it is possible, right? So that is the one reason. So that is why I'm considering the term overfitting over here.
So, what can be done to change this?
We have to tune our parameters. Like for SVM, there are two parameters I told you, gamma and C, right? So you have to keep tuning our parameters. This is more of hit and trial method. We know if we have larger gamma values, my decision boundary will become non-linear. If I have smaller like values, my decision boundary will be more generic. If I have higher C values, if I have lower C values, how it will affect with C. If as C, the value of C increases, my margin decreases. Thus hard SVM. If C की value is very small, the margin increases. Soft SVM. So these all things you should know, and then you should work on your algorithm. You can just keep changing one and you can see what kind of result you are getting, what kind of accuracy you are getting, and then you can go for it. That is how we tune our model. There's something called optimization of model, tuning of model, parameters. So these are all required, and this you will get with this only.
Thank you.
So again, taking different gamma values, I'm taking gamma 10 and C10, and I can see again these decision boundaries. You can see the, if I'm again run it, it will generate a different kind of image because I've just randomized a not okay. So if you can see these values are not being even classified again. So there's again some error with my gamma values or C values which needed to be fixed, right? Unlike in this, everything was getting classified, all the three classes. Okay. Again, I'm over here taking gamma is equals to 100. So it is more like it's the large gamma values which I'm talking about. Again, see how my classification is done. For individual points, the classification is being done. Now you can consider it as overfitting, right? Gamma is equals to 100.
Yeah.
This is what
It
I'm
now
saying. me show you.
It now becomes a sort of KNN classifier. It resembles that
Yeah,
KNN
again,
classifier.
I'll go into the KNN classifier. That is again, it's a different story. Let's stick to the SVM first, because if you're going to merge the concept of KNN, that will be totally different. So yeah, KNN, what you're saying is a clustering thing, right? Let's not go into the clustering right now. What I meant is, if you'll just visualize these three pictures, just these three. So over here, my gamma was 1, which was pretty small, but again, my classification was almost, it was giving a good classification, but again, I'm getting some green patches, which is not good. Then again, I thought, okay, let's increase the gamma values. Then again, I can see some of the classes are being misclassified, but some boundaries I'm getting. When I kept my gamma is equals to 100, I can see it is classifying my all the data, all the classes, take considering as single data point. See, for each red boxes, it is creating one separate, area to classify it, which is not good. This is what overfitting is. This is, you will get, maybe you can get 100% accuracy over it, because all the classes are being classified, but this is not correct, right? That is why overfitting term is uh, introduced. Because right now, if I'm going to add a few handful of more data into it, randomized data, that won't be get like that won't be classified accurately. Okay, so that is why I have written this line. From the above plots, we can see that when we increase the value of gamma, the decision boundary becomes non-linear and leads to overfitting. Okay, so that is why we generally prefer small value of gamma, and there's no thumbs rule, or there's no any specific rule that what should be the value of gamma. That is where we comes in. That is where we have to work on. We have to see for which data set, or which kind of data set, what kind of gamma values work better. But yeah, there's a some generic rule, which is gamma should be less, c should the regularization parameter should be high. That's it. Okay.
Kaushiki,
Yeah.
just a clarification.
Yeah.
So gamma values, if you want to physically interpret these and represent the decision boundary, here what is happening is, for high gamma means the curve, the basis function falls off very rapidly from the target point, right?
Okay.
So the sphere of influence is just restricted to that particular
Sorry.
target data point, right?
Sorry, can you repeat this part if you're
Yeah, I am saying that since gamma is very large,
Mhm.
that means the RBF function falls off very rapidly from the target test point, right?
Yeah.
So the sphere of influence of that data point is just restricted to the point, right? It's not
Yeah.
considering the other target points in the close neighborhood, right?
Mhm.
So that is why probably it's getting so much overfitted. Probably.
You can say that. That is a good analyzation. Actually, it's a good analyzation. So yeah, we can actually say that.
Yeah. Thank you.
Okay. So we talked about two parameters of SVM. There's another something called, I told you, like, why support vector machine came into the picture. If we already have linear regression, logistic regression, one was taking care of regression problems, one was taking care of classification problem, then why do we need support vector machine? Not just because it is taking care of both classification and regression problem, but because there are problems which are not linear. So I don't know if this image is visible. I should have taken some other image. Okay, so if you can see, there are blue data and there are red data. Let's consider it that. Now if I want to separate it, how can I do that? Please do not tell me that let's make a circle and we can separate the that. No, because we that is not how my what we are working is, we are trying to distinguish the data with the help of a straight line. Let's think of that, how you can do that. So this is where the increasing of dimension or a higher dimension thing comes. Just I'll tell you how, but just look into the second image where you can see the three lines, or you can see three dimension. Now here, over here, just drawing a straight line, you can separate the blue data and the red data, right? So this is what my kernel does. Kernel with support vector machine takes the non-linear data into the higher dimension, and over there it linearly separated. That is our motive is, right? So what are kernel is? Kernel are just mathematical function. I told you in starting, if you want to know, for example, it's just an example. If I have a a mathematical formula like a plus b ka whole square, if you consider it as one dimension, and if you will expand it, a square plus b square plus 2ab, you can consider it as three dimension. So the same formula has been taken from one dimension to three dimension. Similarly, with mathematics, that is we termed as kernels, our non-linear data are transformed into a higher dimension, and there they are linearly separable. So that is where kernel functions comes in. There are so many different kinds of kernel functions. Over here I'm going to handle few of them. So yeah, I think I should have taken this in the last. Okay, let's do one thing. I'll come to this cell in the last. Let's go with one by one, or I can show you right now. So basically what I have done is, I should have considered this cell in the last. I have just created different kinds of kernel in the same figures to show you how with uh, different kernel the plots are being done. So what I have taken is, I have taken soft SVM with linear kernel, soft SVM with RVF kernel. RVF is a by default kernel function for SVM. Okay, and similarly for along with SSoft, I have taken hard SVC with linear kernel and hard SV with RVF kernel. Okay, so we'll go. I'll just show you. I'll come again on this. I just wanted to visualize how the linear kernel and RVF kernel. RVF kernel comes when there's a non-linear data is there. So if you can see with soft SVC, the lines, how the lines are. Just see the decision boundary, nothing else. Don't say anything else. And same with the RVF, soft RVF, you can see how the decision boundaries are. Similarly with hard, you can see the decision boundary. That is what I wanted to visualize. So you can now understand what I meant was, but what I meant when I say linear separable, non-linear separable, and how these kernels are coming into picture. Okay, so let's go. Let's start with polynomial kernel. Polynomial kernel are the kernels where we have different degrees. Like again, if we are talking about x plus y plus z, or x square plus y square plus z square, x cube plus y cube. So these square, cube, these are all degree, right? So polynomial kernel function have certain degrees. Over here, what I have considered is degree 8. You can consider anything. Why I have considered 8? There's no question in that, because I just consider it to show some example. So I'm just again importing my SVC, that is my support vector classification, and I'm calling my kernel, that is poly, that is already defined in my sklearn. That is the beauty of sklearn. Like so many libraries are already there. We don't have to put so much effort in making those library or making those function. Otherwise it is so much of task where you have to, the algorithm you have to put it into Python and again do it. You just need to call sklearn, and just you need to use those kernel.
We
So
can also define our own kernels, right? For
obviously you can do
specific
that.
purpose.
Obviously you can do that, and that would be a great research if you're going into that kernel thing.
Okay.
Yeah. So what over here, what I'm considering kernel functions are some reowned kernel function which are almost used in so many algorithms. So I have considered this. First we are doing with polynomial kernel. Yeah, so my kernel is being called. Again the same process. Classifier, we have to fit it, x train and y train, we have to predict our test data, and then we have to produce our, we have to do some evaluation, right? How my classification is done. So right now whatever I've showed you, I showed you in the visualization thing. I wanted to show you how my decision boundary works in, where do you will see how the classes are being classified. What, when we work with the data, we have to work not with the visualization. Visualization is just a part where you can prove your result in a better way. But the most important way is to see the accuracy report. And accuracy report, how it is done with confusion metrics or precision recall. There are certain evaluation matrices which we have to work on. So if you can see the first, this is my confusion matrix, and these are my precision recall, right? Accuracy, if you can see, it is around what macro average, weight average, 83, 86%. So this is what I'm getting, right? This is a classification report, it is called, for my polynomial kernel. Moving ahead, we will do a comparison with all the kernels, which is giving a good result. Okay, we can do that as well. So there's something
What is
called
the support? What is the support? This is the number of data points, is it? Support?
exactly. So that support vector machine, that support, how many data points are being considered, right?
Yeah. Okay.
What's a F1 score?
Okay, these are matrices, like evaluation matrices, um, like how mean, standard deviation, variance, covariance, these are calculated. Similarly, in classification, something called precision recall, F1 score. So I have told you about true positive rate, false positive rate, true negative. So this is with the help of these, precision recall and F1 score are calculated. You will just Google it and you will get in one line. So I don't want to get into that. Just have a read. It's just an accuracy report. It just tell how, like, for example, I can tell you about precision. For example, it is uh you are going to predict on some data points, and you are telling ki, okay, this is my data points and true positive should be this much. So what exactly true positive is, for example, out of 100 dogs pictured, there are 90 dog picture. Okay, and your model is able to identify 80 dog picture. Okay, so your precision would be, that is how your precision would be collected. Out of 90, which is true, 80 dog pictures are being classified. So that is where your precision will be calculated. True values, which is actually true. Okay. Similarly, there are recall, there's F1 score. So I think you should read about it. You can easily get it. And if not, then let me know. I'll happy to help in the next class. Again, there's something called Gaussian kernel. And in Gaussian kernel, I have taken this RVF. RVF actually belong to Gaussian kernel. So I hope if you guys know about Gaussian curve, the bell-shaped curve. So again, the same thing. I'm calling my SVC, the kernel RVF, training it, testing it, predicting it, and generating the report. Okay, so I can see my accuracy is around 83, 87. Precision recall is there for. We will do a comparison purpose as well. There's something called sigmoid kernel as well. These are different kernel, actually mathematical formula. If we go back to our 10-12 classes, you must have heard these kernel name which I'm telling in the form of a mathematical, some formula or some algorithm you must have heard. Sigmoid, Gaussian, these all you must have heard. So kernels are nothing but just mathematical formulas, mathematical equations. I would rather say that. Okay. Now, done with my, I have taken three kernel function. Done with that. Let's see the comparison purpose. If you can see, precision tells about more of uh, the prediction you have done, how much is correct to the true prediction. So if 90 dogs should be classified, 90 dogs are dogs, and your model is able to classify 80 dogs, this means it's a pretty good model, right? Like just 10 not able to classify, it's a very pretty good. But if your model is just able to identify out of 90 dog images, they're just able to identify, use, let's say, 40 dogs images, and rest they're saying no, they are cats, or they're some different species. The model is not good. So that is how we do a evaluation, how my model is working. So if you can see, for sigmoid, my precision is for first class, this 0, 1, 2. Okay. So these 0, 1, 2, this is my classes which we are working on. 0 is my first class, 1 is my second, and second is my third class. Okay. So for first class, precision is 0. One is 0.22 means 22%. Yeah, means it is able to classify first class out just 22% of the first class. And second is zero. Macro average and weighted average, these are just the mean kind of mean average and sum average that is different. So this is also 7% and 5%. So without looking at any other kernel function, just with the classification report, I can totally say this kernel is not at all applicable or suitable for my algorithm. Why? Because they're not able to classify my data. This might not able to classify my classes. So what is the use of using this kernel? That's it. So, okay, this is how we analyze a report, classification report. Let's go with this. If we'll go with this, we can see this is what my Gaussian kernel classification report. We can see macro average accuracy is around 83%. Weighted average is 87%, which is pretty much good. If we'll go with precision, for the first class, that is 0, precision is coming 1. This means it is able to classify 100%. Obviously, you have a question that it may overfit, right? Let's go to other classes. If other two classes are also like, very high, it may, but not necessarily. Again, you have to see other evaluation matrices as well. We cannot take any decision that my model is overfitting or underfitting based on just one evaluation matrix. Okay, make sure of that. So if I go with first class 1, I can see 50%, 56% of data is being classified, and the second class 92% of data. So what we can say is my classification report on my this Gaussian kernel is able to classify my data pretty well. That's it. That's what we can say. And similarly, if I'll go with polynomial, again I can see with polynomial, my precision is for first class is 100%. For class 1 is 62%. For class 2 is 88%. Overall, 83% and 86%. Again, for the same, this my this kernel, polynomial kernel, I can say my classification report is pretty much good. So what I meant is, in a nutshell, I want to say for SVM or for any machine learning algorithm, evaluating your report in terms of confusion matrix, precision, recall, F1 score, there's so many other matrices, evaluation matrices. You have to see how your model is performing, how your model is giving results, and then only you can make any further decision. Okay. So yeah, I took care of hard and soft SVM, different parameters, SVM kernels. I have done the visualization. I have done the classification report. So I hope I have considered most of the SVM part. Do let me know if you have any question. We still have 5 more minutes. Please let me know.
Kaushiki,
Yeah, please tell me.
I've just attached a YouTube video in the chat that shows how you can separate data in higher dimensions, just for the fun of it. So,
Yeah.
in case you may watch too.
Yeah, sure. Thank you. Thank you for that.
For reference. For the reference, yeah.
Thank you so much.
Ma'am,
Yeah, please go ahead.
could you please explain all these matplotlib functions like tight plot and all?
Sorry, I'm not able to hear you. Can you please repeat?
Ma'am, can you please explain explain the functions of matplotlib which is mentioned in here very well?
Okay, you meant the precision recall.
No. Matplotlib function.
Matplotlib. Okay, so
No. Not that matplotlib. Matplotlib functions which we have mentioned in the coding in our
okay.
code.
Just give me a minute. I'll again share my screen. Can you just let me know where I have to stop? Because okay. So what you're talking about is matplotlib. Which exactly cell you're talking about? Can you please let me know?
Tight layout and all.
Uh,
Legend, tight layout.
okay, these plt dot title and all. Are you talking about these plt dot title, plt dot
Only tight layout and legend.
Yes, you're talking about these all, right? Title, legend, title layout. Okay, so legend means this thing. Okay, I'll just tell you. So legend, I over here plt dot legend means this thing. What are the things that has been used? That is the legend. And loc I have written upper left means I'm defining its position. If I'm doing it anywhere upper right, see if I'll just do the upper right, if I'll run it, it will go to the right side of that. That's it. That's just, can you see this? It went to the right side. That's it. And plt tight layout means that this the boundary you are seeing na, that means I am just saying dot dot title. It's not necessary. It's just I want, it's a way of representation of your you know diagram. That's it. So I hope I'm clear. That is what you are asking, right?
Means we are only mentioning for our representation as a boundary layer.
Yeah. Nothing much. See, what important among them is this plt dot title, which tells you what is the title of your this. Then there will be axis. You have to define what kind of axis you have taken. Over here, I have not defined because there is no need of that. But if you can see where there is need of that, I must have defined my axis. If you can see over here, this sepal width and sepal length, I have defined my axis as well, right? So this is
Ma'am,
what,
hello.
yeah,
Ma'am, ma'am, please upload the tutorial
your
in
voice
YouTube,
is,
new YouTube
sorry,
channel.
sorry. Again, hi, again, please. Can you write it on chat box? I can read it right now, right?
The video we have to upload in your new YouTube channel, ma'am. We are following
Oh,
that.
YouTube channel, the link was wrong. Okay. Okay. You can just search my name on YouTube. You can get it. I'll just write my name.
As much as possible soon that we have to upload now.
Sorry.
Because why? Why? Because we are login late. So
Okay. Yeah, surely I'll upload it. You can just search with my name as well. And I doubt why you guys are not able to.
already subscribed, ma'am, in your YouTube channel.
Yeah, you are able to see my YouTube videos, right?
Yeah, ma'am.
Yeah. So if you want, again, I can share the link. Yeah. Anything else?
Case index.
Sorry. Okay. So talking about pre-processing of data and working on that, definitely I'm going to take. I'll try to take it in the next class if I'm not allotted with some other topic. If not, then maybe some other class. But yeah, definitely I'm going to take the pre-processing and how taking a raw data you can do any kind of um, algorithm in that. So okay, so thank you for today's class. See you guys next week. Bye.